Well, hey gang, let's move forward and let's talk about solving compound inequalities. Now, compound inequalities where we've got two inequality statements, and they can either come in the variety that we would call an and, or, an or an or. How about that? Okay, well, maybe it'll make more sense in a moment. Let's first look at and. And let me just say from the beginning here that the trick is usually not in the solving of the inequalities, it's in the graphing of the inequalities, and we'll be graphing on a number line. So let's look first here at and statements. So let's see, a compound inequality containing and is true only if both of the inequalities are true. So if we got an and statement, then it is only true if both inequalities are true. The graph is where the two inequalities overlap, and we call this the intersection of the two graphs. So let's first take a look here at a couple of and statements, and we're going to show how they might be presented to you in a couple of different ways. All right, let's look here at a couple of compound inequalities where there are and statements. Let's start off. Let's say that we're given this, y minus 3 is greater than or equal to negative 11, and y minus 3 is less than or equal to minus 8. Well, we got to kind of break here because they actually put the word and in what we have to solve. So we know that this is a compound inequality that is an and statement. The graph is going to be the intersection of the two graphs. It's going to be where the graphs overlap. So let's just first start by solving both of these. So I'm going to start over here on the left. And so if I got y minus 3 is greater than or equal to minus 11, if I isolate the y, I'm going to add 3 to both sides. And when I do, I'm going to end up with y is greater than or equal to negative 8. And over here on the right, I've got y minus 3 is less than or equal to negative 8. I'm going to add 3 again to both sides. And so I'm left here with y is less than or equal to negative 5. So let's draw a number line here right quick. And I got 2 points I got to consider. I got negative 5 and I got negative 8. Okay, so let's start. On the left, I got y is greater than or equal to negative 8. So I know that I'm going to need to put a closed dot here at negative 8. Okay. And so if y is greater than or equal to negative 8, I'm going to be headed in this direction, right? Yeah, sure I would be. Now, let's take a quick look here at y is less than or equal to negative 5. Well, again, I got a less than or equal to, so I've got a closed dot. Okay. And I know if I were to graph that y is less than negative 5, I'd be headed in that direction. All right, that still hasn't completed my graph because when I'm dealing with an and statement, it's got x, or was this case, excuse me, y has got to be a value that makes both statements true. Now, let's say, and what I can do is I can actually test these intervals if I get confused. So let's say that y is equal to, get another color here. Let's say that I'm looking at what happens if y is equal to negative 9. Well, if I plug in negative 9 right here, well, negative 9 greater than or equal to negative 8, well, that's not true. So that's not true. And let's see, what if I put over here, let's say I'm looking at negative 4. Well, if I plug in y, negative 4 for y right here again, well, I got y is greater than or equal, negative 4 is greater than or equal to 8. Well, that's true. But what about over here? When I plug in negative 4, is negative 4 less than or equal to negative 5? Well, no, that's not true. All right. Now, I got my 2's closed dots. Let's pick a point right here in the middle. Let's say say negative 6. Right? Negative 6. If I plug in, excuse me, if I plug in negative 6 for y in this equation, or this inequality, I got negative 6 is greater than or equal to 8. Well, that's true. And what about over here? Negative 6 is negative 6 over here. Is negative 6 less than or equal to negative 5? Yes, that's true. So on my graph, what satisfies both inequalities is right here in between the negative 8 and the negative 5, and this is what we would call the intersection. And this is what is characteristic of an and inequality. And there's my correct answer right here. All right. Now let's take a look at how it might be expressed to us in just a different form, which can confuse us even more, but hopefully not too bad. Let's say we've got 6 is less than or equal to r plus 7, which is also less than 10. Now, here we didn't catch a break. We've got one big statement. But if I read this, I've got 6 is less than or equal to r plus 7, and r plus 7 is less than 10. And I'm going to solve these by breaking these apart. So I'm going to start here with 6 is less than or equal to r plus 7. I'm going to subtract 7 from both sides, and when I do, I've got negative 1 is less than or equal to r. Then I'm going to take this same thing over here, and I'm going to have r plus 7 is less than 10. I'm going to subtract 7 from both sides, and so I've got r is less than 3. So let's get us a little number line here. And I got two critical points. I got negative 1 and I've got 3. Those are my critical points. Okay, so I got r is greater than or equal to negative 1. Well, I've got a greater than or equal to. Let's put in here a closed dot. Closed dot right here. And here I've got r is less than 3. Well, that's just a less than, so I've got an open dot right here. Okay, now I've got to try to figure out where I'm going to graph this thing. Now, the and statement should tell me it's probably going to be between this point and this point, but let's see if we can't prove it. Let's test out a point negative 2. Well, if negative 1, if I plug in negative 2 for r, negative 1 less than or equal to negative 2, well, that's not true. So this interval right here would not be true. And let's say I pick a point right here, 4. Well, 4 less than 3, well, that's not true. Okay. Now let's pick a point right here in the middle. Let's say 0. Okay. Negative 1 is less than or equal to 0. Well, that's true. And how about, is 0 less than 3? Yes, 0 is less than 3. And so the graph of my equation is going to be the intersection right here. And that's the graph that makes both statements true. Remember, I got a closed dot here because I got a less than or equal to, and on this side I've got an open dot because I've got just a less than statement. Okay. I'm sure we'll have to practice this some, but look for an and statement to show you if it's an and statement, the graph is going to be the intersection. It's going to be what makes both statements true. All right, now let's move on in this world of compound inequalities. Let's talk about some of the characteristics of an or statement. So a compound inequality containing the word or is true if at least one of the inequalities are true. And this graph is what we call the union of the inequalities. So our solution set, it would be any number that makes either of the inequalities true. And what would not be included would be any number that is false in both inequalities. Okay, we got to hang together here. Keep our heads on straight or we can lose it. Let's look at a couple of examples. Now, one of the nice things about a compound inequality that's got an or statement is there's usually the word or in our expression. So let's look at what we got here. I've got a plus 1 is less than 4, or, see, catch a break here, telling us it's an or statement. A minus 1 is greater than or equal to 3. Okay. Now, once again, I'm going to solve both sides of this. I don't know why we got the little, oh, that's a plus. Okay, that makes more sense. All right, so let's see. If I'm going to isolate the a, I'm going to subtract 1 from both sides, and so I'm going to end up with a is less than 3. And over here on the second part of the equation, I'm going to add 1 to both sides, and so I'm going to have a is greater than or equal to 4. All right, so let's get a number line. I got two critical points here. I got a 3 and a 4. All right, so let's go over here on the left. I've got a right here. A is less than 3. So I know with my 3, I've got to get an open dot. I'll go ahead and get that put in here. And then over here on the right-hand side, I've got a is greater than or equal to negative 4. So I know at least I got a closed dot. Okay, now, generally speaking, on this side, if I'm going to go with a is greater than, or less than, less than 3, I know my graph is going to head off in this direction. And then over on this side, if I've got a is greater than or equal to 4, I know my graph is headed off in this direction. Now, what I want to do here, since I'm pretty well satisfied with that so far, I just want to make sure that whatever's here in the middle is not included. In other words, this would be something that would be false in both cases. Well, I got between 3 and 4. I'm going to put it up here. Let's say we're going to test 2.5. Okay, so 2.5 is less than 3. Well, that's not true, right? 2.5 is not less than 3. That's not true. What if I put in over here 2.5, substituting in 2.5 for a? 2.5 is greater than or equal to 4. Well, that's not true. So remember now, I know all of this right here is true for this one. And I know that all of this right here is true for this one. And I know what's not true for both of them is right there in the middle. So, hey, I've already graphed it. That's the characteristics of an or statement graph. Now, being math and being what it is, they will try to trip you up sometimes. Maybe all the time. So let's look at this. I got x is less than or equal to 9, or, once again, we call it a break. We know it's an or statement because it's got the word or in it. 2 plus 4x is less than 10. Well, hey, I caught another break because over here on this side, right here, I don't have to do any solving. It's already there. X is less than or equal to negative 9. So the only part I got to solve is over here on the right. And so I've got 4x. I'm going to subtract 2 from both sides. So 4x is 8. 10 minus 2 is 8. And then I'm going to divide by 4 on both sides. And that's to isolate the x. And so I got x is less than 2. All right, so let's get us a little number line here. I got two critical points. I got a 2 right here, and I've got a 9 here. Okay, and over here in the less than or equal to, at the 9, I've got a closed dot. And here at 2, I've got an open dot. An open dot right here. Okay, so let's think about where my graph is going. If x is less than or equal to -9, I would think from this point on, I'm headed in this direction, less than or equal to. And here I solve down that x is less than or equal to 2, and so I should be headed in this direction. And it's got to be a number that makes either statement true. And this is where the trick comes in on this one. So let's just test some points. So how about right here, I decide, okay, 1. Well, is 1 less than or equal to 9? Yes, that's true. And over here is 1 less than 2. Checking a point here, 1 less than true. Yes, that's true. Okay, so both of those are true. So I know I at least got right here. Let's test the point between 2 and 9. Let's say 5. All right, is 5 less than or equal to 9? Yes, that's true. And is 5 less than 2? Well, no, that's not true for this one. Well, let's go ahead and test one point out here. Let's test 10. All right, is 10 less than or equal to 9? No, that's not true. And is 10 less than 2? No, that's not true. So this entire interval right here is not true. But what's tripping me up here and what I can't figure out is, although I'm going to figure it out, this interval right here is not true for that statement. No, it is true for that statement. The 5 is true. If I plug it in, 5 is less than or equal to 9, but it's not true for this one because 5 is not less than 2. But remember, it's only got to be what will make one of the two statements true. That is our solution set. And in this case, I actually just have one big line going all the way right here. Okay. We'll talk about that more in class, but this is where they can confuse you on the or statement. Usually it's fairly straightforward. It looks something like that. You just graph either side, you're done. Here's the burn, is when you got an intersection, you got an interval that makes one of the statements true but not the other. And that is a burn notice.